Good morning, all. Nice of you. I'm sorry for special class. Okay, we will start with the work on the detection of gravitational waves and the black holes as a landmark experiments. These are two topics earlier. Black holes were studied in a different way, and the gravitational waves were studied in a different way. And these are the waves only. And way back to the 1950s, when Einstein was there, during his era or the period, there was a very fantastic discoveries on several phenomena. Discovery of gravitational waves was also one among that, based on his theory of general theory of relativity, where some kinds of waves were postulated, some kinds of waves were identified by his theory, and were there were no experiments for its detection, or there were no experiments to make the evidence for his theory. Let us say that being this is the illustrations given by the NASA, particularly from the Hendrix lab, on gravitational waves produced by the two orbiting black holes. You are well witnessed with the different kind of waves, either sound waves, mechanical waves, or maybe light waves, or maybe different kind of a waves, even waves in a pond, waves in a water body. If you put any type of an obstacles or drop any kind of an obstacles, you will see the waves formed actually due to the disturbances which caused. These waves are nothing but the propagation of energy from the source outward, preferably, maybe in a different direction, a spherical direction only, spherically outward. As they move outward, their intensity or energy or power or maybe peak in intensity drops, as that is almost an similar behavior as that of the electromagnetic radiation. Kindly concentrate on the left side. He's here. See that there is a pond. Maybe two kind of stones were fallen actually here. It created. This is the one. This is the center part. Is source of disturbance. Waves are propagating outward radially. Here is the one. Compared to the left, right one looks like with a higher diameter. Maybe the disturbances which was formed maybe an earlier than the left one. Those two will collide here, overact here, interact here actually. See that interactions can happen with some kind of a ripples, they can say that. The similar behavior was also found in black holes. Let us restrict this to this now. We will come back and discuss in detail in few minutes or in few next slides actually. Gravitational, the right side shows that this is one kind of a black wave, this is another kind of a black wave, sorry, black hole they can call. Both generates the waves in different directions. It is shown in such a way that it's towards the right of its path, towards left, ahead of you, towards you. This is also same case. There may be a possibility of the waves to merge, waves to interact actually. That interactions can be detected, that interactions can be monitored, that by knowing those interactions, one can have the inference on where the source of disturbance has started, what kind of a source, what was when it was formed, and how long it was traveled, or how far it is right now. Those type of things can be detected in the universe. Gravitational waves are ripples in space-time. That is, the space means between the path. Time domain means either it can go back or may go forward. It is fabric like a fabric of universe. It is a fabric. What you can call fabrics in a fruits, fabric in and vegetables of that kind actually, caused by massive objects moving with extreme acceleration. If an object is said to be at stationary, it may not generate any kind of a waves like a gravitational waves. Okay. If it is moving, certainly it has to generate. In the sense, I'm not saying that rest bodies doesn't have a gravitational force. Gravity, by virtue of its mass, all objects in the universe, starting from the elementary particle to the gigantic supernovae, we are having a gravitational force. Those gravitational force acts other bodies. A body in the universe is acted upon by any kind of other body, or a body in the universe influence all objects in the universe through its mass by generating gravitational force, right? The virtue of its gravitational force. But If those objects are moving, certainly the moving objects have to have an acceleration. Maybe you can call, if it gets slowed down, you can call it as a deceleration. If the speed picks up or rate of change of velocity enhances in any particular direction, we are calling them as the acceleration. Okay? If it reduces, it can call it as a deceleration. Maybe the deceleration is associated with the negative kind of a velocity. In outer space means not within the atmosphere of any Earth or any of the planets. Objects like neutron stars or black holes, which are orbiting around each other ever at ever increasing in rates, or stars that blow themselves up into the supernova. These are some of the examples actually. Means like neutron stars. They are emitting in the gravitational fields, or black holes orbiting around each other, not a single one. Because if it is a single black hole, it may not it may not be an accelerated to a greater extent. If that is, there are two minimum of the two. For example, if the two black holes are at finite distance, they are attracting themselves and they are accelerating inward. Actually, accelerating inward at that moment because of the gravity. They generate a wave. Those waves are known as the gravitational waves. Even stars which can blow up. Blow up means expansion of the stars due to the time. The time still birth of the star till to the end actually as a dwarf and supernovae, white dwarf and the giants actually. This becomes in such a way that they will expand because of the supernovae of the expansion. This generates an gravitational waves. Or a gravitational wave is an invisible, of course, yet an incredibly moving very fast ripple in space. Ripple, see that these are the ripples. These are the waves actually. Similar to this, you can see on the water body, you can see on the media of any kind of a fluid actually, waves which are forming or disturbances which are moving from the center or the source toward away from that. The between these massive objects, celestial objects, also we are having the ripples in space, but they may not be visible in the visible radiation or between 4000 angstrom to 8000 angstrom. Gravitational waves travel at the speed of light in vacuum. Almost this is what you got. 3 into 10 to the power of 8 meter per second or 3 lakh kilometer per second is the value for the youngsters or not for you. Since for all practical applications to make the calculations simpler, you can use. Otherwise, you use that 2,99,000 what 2,99,000 7 and 8.48 kilometer. How actually 2,99,792,458 meter per second. Otherwise, if you convert, this becomes up to this is the kilometer second. These waves squeeze like any kind of soft drinks you can squeeze, no, the same case, and stretch anything in their path as they pass by. Either they can squeeze themselves or they can stretch. Okay, because as the waves interacts due to the Doppler effect, because of approaching, they may squeeze, or if they are moving apart, they may be sparse by. A gravitational wave is an invisible but yet incredibly moving fast ripple in space that is an equivalent to the speed as that of the speed of light in vacuum, being this water gravitational waves. Don't get hurry. These are the statements which are going on. There is no need for you to write in the examinations this type of the diagram, or if you write, mention at least as a schematic representation. This is the Earth. Due to the mass, it is like it is a sinking one. This is the space-time curve they can call space-time curve in the sense on the spatial coordinates, either towards whichever with the coordinate system you can call actually along the x, along the y as the vertical, and z is towards you or away from you of that kind. A satellite is which is being around the Earth should also have a mass. A two-dimensional illustration of how mass in the universe distorts the space-time actually. If being this is a straight line without mass. If you take the mass according to the mass, you can have a distortion. Heavier masses will have a larger distortions. You can expect that where it dip In it, actually, lighter masses have a smaller dimensions. Like this, the space-time curve holds all planets into the solar system, or all stars in the galaxy, or all galaxies in the universe. We'll check it one by one. Actually, we'll see that what best one can see that. What are gravitational waves? Simply from the Newton's laws of motion or from the Newton, you thought that gravity is mainly a force which is acted upon on any two massive objects. Fine. This is also same case. Instead of that, the gravitational waves are the one which are the ripples in space-time, which are caused by some most violent and energetic process in the universe. Violent in the sense if they are very active. That's why they are calling violent actually. Okay, and most preferably, they are energetic processes in the universe. These are the ripples. You can expect that. Ripples are the one you can see here in a circular manner. Albert Einstein, around 1916, of course, in 1916, he gave a general theory of relativity. He was working on phenomena of space-time. Space and time is the only domain where very less people are working right now. Services from last more than 200 years. Einstein predicted, Albert Einstein only, predicted the existence of the gravitational waves in 1916 in his general theory of relativity, almost 100 13, 7 or 8 year of that kind, like 1 or 2 years. Einstein's mathematics, it is a prediction only, it is no experiment at all. He was a great mathematician and he was a great theoretician, showed that massive accelerating objects, anything, whatever you can call, massive accelerating objects like neutron stars or black holes which are orbiting each other. Neutron stars will not move each other actually. Movement of neutron stars or the black holes which are orbiting each other would disrupt the space-time in such a way that waves of undulating, unmodulated space-time would propagate in all directions away from the source. Assume that you are having a tuning fork, you just vibrate the tuning fork, it generates a frequency, it generates waves. Those waves will propagate. And if there is another tuning fork near to that field, without the impact, without having an impact, it oscillates on its own. You are listening to me through some mode in such a way, the voice from me is generated and traveling to you by some other technique. In the real class, offline classes, whatever I speak, you listen to me mainly because the sound energy propagates in a media and reaches your ears. Of course, since you are on and being an online class, the mode of communication, the mode of transport of energy is different. It is not like an acoustic of that kind. A wave from acoustic is converted here and can gets modulated and gets transmitted through some electromagnetic, some electrical energy, and then reaches your mobile. From my mobile, it generates a waves that is in the sound form and that reaches you if you are using an earphone or maybe directly listening to the intensity, like directly listening to the sound actually. I hope all of you are following, are able to see the slide and able to listen to me.
Yes, sir.
Fine, fine. I'll continue. Okay, means orbiting jet. These cosmic ripples, what you are expecting, would travel at the speed of the light, carrying with them the information about their origin, means as well as clues about the nature of gravity itself. This is the remarkable idea. See, think that whatever you are working now will fetch you the results later. It is not an instantaneous, like in terms of the recognitions or in terms of the modifications. Even though Einstein worked out during 1916, almost 100 years, that work was not uh, experimented or there were no experiments to prove his theory. Around 2017, three great scientists have shown from the LIGO laboratory about the existence of the gravitational waves, where those waves were generated 100 years back, or not 100 years, about 1.3 billion light years. 1.3 billion light years actually that was identified, and that a Nobel committee gave a Nobel. That is a different story. I will explain in 2 minutes to a great extent, or maybe later half of this talk. These cosmic ripples would travel at the speed of the light, almost what you expect, 3 into 10 to the power of 8 meter per second, kilometer per second is the one carrying them, carrying with them the information about their origin. For example, if something is coming from somewhere, if you are smelling somewhere, the smell, maybe smell of a sweet, smell of a food, smell of a fruit, smell of a vegetables, smell of a flower, means that is a fragrance of a flower, then you can expect that where the source is there by virtue of the smell, that is one of the sense organ through the nose, you will detect it. Nose becomes the detector for that actually. If I clap here right now, you will able to listen to me. Of course, if it is a direct visibility, you can expect that where you can have the source of that sound actually. Similar to that, instead of sound, these waves, electromagnetic waves, are traveling throughout the universe, and one can detect at what must be the possibility of the position of the source actually. In a way back, we can go back about last 100 year back, 200 year back, or billion years back actually, if the intensity of the radiation emitted by such an object is quite large and we can detect now itself. Okay. The strongest gravitational waves are produced by a cataclysmic events such as colliding black holes. This is the huge one actually. Cataclysmic, like an seismic activity. This is of that kind. This is of that kind actually. This is of that kind which colliding black holes, supernova, massive stars exploding at the event and their lifetime. Sorry. Okay. Some disturbance. The strongest gravitational waves are produced by the cataclysmic events such as the colliding of the black holes. You imagine they are very strong one, and even the supernovae, massive stars exploding at the end of their lifetime may collide. Okay, this is the supernova is not one single event, a single massive object actually. So many stars were put together, and if they are supernova is exploding because of that expansions, the heavier mass stars collide, and colliding of the neutron stars to a great extent. We'll see that. The other gravitational waves which are predicted are caused by rotation of neutron stars, even for the angular rotations that are not perfect spheres, and possibly even the remnant of gravitational radiation created by the Big Bang. The most powerful gravitational waves are created when objects move at very high speeds, when stars explode asymmetrically, like a supernova, or when two big stars orbiting each other, or when two black holes orbit each other and merge. That is the one, the generation. These are the few examples where you can witness actually a great deal for you to study, a great deal for you to opt any of the elective courses. Of course, the department is open with several special papers for you during third semester. You opt well, actually. I will explain later. This is how it will go. We'll move to the next slide. Wow, such a beautiful thing. You may not be appreciated in an offline class. I can't show you this type of things in a dry blackboard or a green board of that kind. Gravitational waves which were detected 100 years after Einstein's prediction. Imagine actually. See, that's why always we request, even for me also, my teachers used to urge in such a way that work hard, and your work will be recognized future as a researcher, as a faculty, as whatever you want actually. Now you work very hard actually, hard in the sense that try to work on the concepts actually, or try to work on the thoughts, try to work on the ideas actually. Your ideas will be seen by the scientific community, your ideas will be received by the scientific community and the public in a larger way if it fetches with the new theories, new experiments, new concepts, new ideas, new what we can call new ideologies actually, we can call actually gravitational. This is not the actual photography, it is an artistic view, animation of the gravitational waves which were created by the merge of two black holes. See, this is one black hole, another black hole. Go under both of them, both are attracting each other. In the background is the stellar phenomena with the different clusters of the stars to a great extent. You can see a one circle, like looks like a circle. This is mainly because of the gravitational influence of the both of the black holes put together there. Even though black hole is the one actually where you can't expect anything inside. Whatever the material which goes in will never come out due to the extremely high gravitational force. But if such type of two events, if such type of two celestial bodies, group of celestial bodies comes closer, certainly the gravity extends between them. There is a possibility that they may collide and become a single black hole to a great extent. This is the one what they expect. But these type of the objects that create the gravitational waves are far away from us. It is not nearest to us. And sometimes these events only cause small, weak gravitational waves that can be detected on Earth. The waves are then very weak by the time they reach the Earth. This makes the gravitational waves very hard to detect. It is not like a very strength force like an electromagnetic waves or sound waves or tsunami waves generated due to tsunami or maybe the cyclones or maybe a hurricane or maybe even what we can call earthquakes. Okay, geostorm. I'm having a one YouTube clippings. If it is possible, we'll just watch it. One second. Are you able to hear the sound?
No, sir.
It doesn't matter. I will share. Just watch. Best to come. Now,
No, sir, we can't hear.
one second, once. I will share this, of course. This is through Zoom. Is there uh, some itches maybe there? Okay, I could not able to follow it very soon. I'm hearing. I'm listening. See that these are the two massive things. I'll show it again. This is how that space time can goes. These are the two black holes. Generate. This is this ripples. These are the ripples which are moving. This is the crest and peak of that kind. My God, see that, see that, see. Whoa, 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 whoa. Okay, here I'll come back to the original class. What animation you have seen that illustrates that how that gravitational waves are emitted by two neutron stars. Of course, two black. Sorry, this is not two black holes. Two neutron stars as they orbit each other and they coalescence. Coalescence they merge together. Actually, it was the animation created by the Goddard Space Center of the NASA. Note that the gravitational waves themselves are invisible. They are made visible here to illustrate their propagation away from the source. Okay, it's not like what you are expecting. I will shall cast one more thing. Wait, it is of larger in size. Yeah, this is with the neutron stars. Okay, It comes hardly 40 seconds. Listen that. You can also see the movement. Oh my God. See, see, this is the representation. It is not an easy phenomena. It is not how they made a guess and worked out. See that because of those two things which are binding each other, gravity acts in a better way. See, they're coming closer and closer and closer, 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 still closer. Where their speed also got enhanced. If they come closer, it becomes a single event. Two neutron stars collide. That is a coalescence. Become one single. It generates the energy. It generates the spectrum. It generates the waves. Those waves were generated at the source formation. Now that has reached us. That is about 1.3 billion year old. They can call billion light years, not old. Old also the same case ago. If you want, you can see later. I will share the same case on time domain. But here what happens? Though Einstein predicted the existence of the gravitational waves in 1916, the first proof of their existence did not arrive until 1974. In 1974, they tried, but about 20 years after his death. Okay, he passed away in 54 of that kind. 54 of that kind. In 1974, two astronomers by name Russell Halsey and Joseph Tyler, using the Arecibo Radio Astronomy Observatory in Rico, discovered a binary pulsars where they were about some 21,000 light years away from the Earth. They detected the binary pulsars. Binary pulsars of the same case, they can generate the gravitational waves. This was exactly the type of system that general relativity predicted should radiate the gravitational waves. Knowing that the system could be studied to test the Einstein's predictions, another two group of scientists, they were colleagues, in fact, Tyler and Tyler, uh, with the Joel Zimmer and the leaf blower, began tracking the radio emissions from the stars to measure how their orbital period changed over time. Orbital period means due to the angular speed, they are revolving with reference to some common center of mass, how that is evolved. They try to put an effort to understand actually. This is the trial versions. After 10 minutes, if it goes, give a gap and log in once again. I need another 40 minutes. After just 4 years from the 74, they first reported seeing a change in the period that verified the stars were getting closer to each other at the rate predicted by the general relativity if they were radiating gravitational waves. If those stars or any kind of the stars, if they are radiating the gravitational waves because of their mutual force of attraction due to the gravitational force that can be detected from the general theory of from general theory of relativity or from general relativity they can call. In 1993, after 74, again next 20 years, Hulse and Tyler received the Nobel Prize in Physics for discovery of a new type of a pulsar, a discovery that has opened up new possibilities for the study of gravitational influence, the pulsars they can call actually. A new type. This is what the fantastic discovery. What they mean? Just think it up. LIGO is one observatory in the universe. Laser interferometer, gravitational wave observatory they can call. The Nobel for the 2017 came particularly for the purpose of detecting the gravitational waves. That was for detecting the gravitational waves. Since then, many astronomers have studied pulsar radio emissions. Pulsars are neutron stars, what we meant by pulsars, neutron stars that emit the beams of radio waves and found similar effects, further confirming the existence of the gravity. But this confirmation had always come indirectly from something else or mathematically which were proven and not through the direct contact or interactions with any instruments. Means either confirmation means even something is emitting the gravitational waves, we can't detect the gravitational waves. Those influence of the gravitational waves will hamper something else, then we can detect it. See, assume that if like in tsunami comes, tsunami sometimes over the ocean, one can see that because of the tsunami, if water waves comes and hits the beaches or coastal line, that is an indirect effect that somewhere tsunami has happened. Okay? And somewhere tsunami has happened. It is an indirect way. On September 14, 2015, about 8 years back, when LIGO physically sensed the undulation is modulation, they can call actually, in space time caused by the gravitational waves which were generated by two colliding black holes. They were about roughly 1.3 billion light years away. BLY is billion light years away from us. Light year is the one, how long the light can take to travel in 1 year is called 1 light year. One light means 1.3 billion times the speed of the light into 365 days into 24 hours into 60 minutes into 60 seconds. You expect that is the distance where where black holes collided. Two black holes collided at that distance, and that light, that energy, even though it was traveling at the speed of the light, that generated the black, what they can call gravitational waves. Those gravitational waves were detected by a LIGO observatory by some technique they can call. Here, this Ligo's detection as humanity's greatest achievement. This is the power, manpower. This is the strength of the scientific community, strength of an human being compared to the others in the universe to detect even such a weak signal, even though it was very far away and emitted way back about 1.3 billion years, and people can think it of what it should be there. We are not aware that what will happen next to our door. We will not know what has happened about last few days back, and we are not sure that what is going to happen future. Means that is in terms of predictions. But Einstein detected those waves in 100 years back. That this based on those theories, based on general relativity, and the scientific community worked on that at LIGO, and practically it detected those waves. On right side, you can see that it is again a pictorial representation of the impressions of the binary pulsars. Means this is one pulsar here, another pulsar here. This is moving from top to right bottom. This is moving from left to the top right actually. If these two waves generates the uh, generates the waves, gravitational waves. If they come in contact, particularly in the mutual gravitational force of attraction, actually, they generate the energy. That energy can be detected. What happened here? We'll see that. While the process that generate the gravitational waves are extremely violent, destructive, by the time the waves reach the Earth, they are thousands of billions of times smaller. See that? Very small, diminishing over time. Diminishing means reducing over time, decreasing over time, and space, just as the waves from far away pebble drop in pond get smaller and smaller as they move away from the source. For example, even if you drop a stone or maybe any kind of an object over the pond, the waves will generate. Of course, you can see through your eyes, but if you want to see the same waves after 1 kilometer distance or at a distance of about some 10 kilometers, is a difficult task. See that such type of a disturbances, even though it is coming from 1.3 billion years away, but the but the energy was quite large actually. But the signal which was traveled after such a long distance was very feeble. In fact, by the time gravitational waves from LIGO's first detection reached the Earth, in the sense on the Earth, the amount of space time which is wobbling, which is generating the peaks, pebbles actually, they generated was about 1,000 times smaller than the nucleus of atom. Means space-time wobbling what you're expecting. That's if you compare actually smaller than the 1,000 times smaller than, instead of not the femtometer, even attometer less than two thousands of attometer of that, not thousand, micro attometer of that kind actually 10 to the power of minus 14, sorry, minus 18, minus 19, minus 20, 20 minus 20 of a meter, just a very small disturbances of that kind actually. I'll stop at this moment. Kindly log in after 5 minutes. I need this time to for recording. Then why one has to detect this type of the waves, that we will think it off. Another 40 minutes. Kindly bear with me. Right now, 10:40. You log in by 40.